Hey everyone, this is lesson 10.2.1 on Introduction to Chords. This is a continuation of our topic of circles. Recently, we've learned a lot about circles. We learned about area, perimeter of circles, how to find the area of a sector, how to find the arc length. So we've learned a few things. We even learned the equation of the circle. So we're going to dive into a little bit more about circles and some relationships that are associated with circles. Similar to some things that we did with quadrilaterals, even though you already know what a shape is with four sides, but there's a lot of extra details and properties that we explored this year. So some prior knowledge that you need to know going into this lesson is what a circle is, some basic parts, radius of a circle, knowing that the radius is the distance from the center of the circle to the edge of the circle. So that measurement is the radius. Diameter is twice as long as the radius. So if you take one radius and another radius in the opposite direction, that gives you a segment that goes from one end of the circle through the center to the other end of the circle, and we call that the diameter. So that could be placed anywhere within the circle. All right, and don't forget that also means it cuts the circle in half, which gives us 180 degrees, and there's a lot of other details that we've covered before. All right, so this lesson is an introduction to chords, which technically we've already been talking about chords, but maybe you didn't realize it. All right, so here let's look at kind of a real world problem that kind of maybe will spark some thoughts. How can we find the diameter of a tree if we only have a portion of it? All right, so if we, in our book, they actually talk about the world's largest tree located in Africa and Australia. This type of tree is so big that it becomes really too large to measure. Right? But what we do have is a piece of the tree. Right? So here's an example. It says a tree fragment. So there's a piece of a tree, and using this information, we're trying to figure out, can we tell how big the tree was initially, even though we don't have the tree itself. All right, so if we look at just the piece that we do have, if I know this piece of the tree represents this part of the circumference of the full tree, right, assuming the tree's somewhat round in shape, can we use that? Can we use just this curved portion to maybe figure out where the center would be, right? Can we find the center of a circle if we only have an arc, right? So if I have this arc AB, can I figure out where the center of the circle is? Is it going to be right here? Well, that looks a little bit too close. All right, we could probably approximate it. We could probably pretend we're drawing a circle and then say, oh, it's probably going to be somewhere around here, right? But how can we make sure that's the exact spot? How do we know it's not here or here or here? So that's what we're going to explore in today's lesson, plus introduce a few more vocabulary terms that you need to know. All right, so I'm going to kind of just throw at you some words and definitions that we need to know moving forward, and then we'll practice a couple problems using this knowledge. All right, so here's kind of a summary of some new circle information you need to know. The first is chord, right, which is really the title of our lesson, Introduction to Chords. So we are familiar with circles, right, and we are familiar with arcs. Now, a chord is a line segment, so a straight line that connects the endpoints of an arc. So in this case, if I have arc AB is this curved portion, endpoints being A and B. If I draw a straight line from A to B, we call this a chord. So technically, we've already been talking about chords for a while now. When if I talk about, let's say, an arc that covers half of the circle, then there's a chord that goes right down the middle, right? So diameter would be another type of chord that we've already been exposed to. All right, so some things you need to know, just terminology. So in this case, chord AB, you'll notice we have a segment AB here, where there's a line on top of the AB to tell us it's a line segment of arc AB. And you'll notice there's like an arc above AB. So if you don't see this notation, if you don't see the notation telling you it's a segment or an arc, then most likely you would see the words arc AB, something like this. So things to look out for. So in this case, there's arc AB and there's chord AB. So try not to mix those up. All right, some relationships that we need to know. That if you have the diameter, so in the second picture, we have a diameter, which I've drawn going straight up and down. And that diameter happens to be perpendicular. Perpendicular means it's forming a 90-degree angle with another chord, right? It says another chord, which means diameter is a chord. And we have another chord, or they intersect, right? Kind of looks like a T shaped, forming a perpendicular angle. So when we have this situation, the diameter also bisects the chord. So the word bisects meaning it cuts this chord into two equal parts, which is why we have this notation. I put these markings to let me know that these two pieces are the same. And it also bisects the arc. So you'll notice the arc above, right? So you see this chord that goes across has an arc, right, of the same endpoints. It also gets cut, this diameter is also going to cut this arc into two equal pieces. So the arc gets cut into two equal pieces and the chord gets cut into two equal pieces. Right? This only happens when the diameter is perpendicular. So I could draw in another diameter that goes a little bit more slanted. That's not going to work the same because it's not perpendicular. So this has to be a perpendicular relationship in order for us to know that the chord and the arc are going to be bisected, right? Cut into two equal pieces. All right, so this is something, all these little details are going to be things we're going to be using to solve specific problems. So that's why I'm just kind of front loading you with this information. So definitely copy that down. You're going to have to get a little bit better drawing circles on your paper. If you don't have the right tools to draw a good circle, you could use something, try to find something that's round that you could trace. Maybe even like a quarter or something. Maybe you have a silver dollar, depending on how big you want your circles. I wouldn't suggest not making your circles too small because then it becomes very difficult to draw lines inside of them. All right, so make them a good size. They don't have to be super large, but they should be roughly around the size of a quarter, or not a little bit bigger if you can. That'll just make it easier for you. All right, so those are a couple of things. The other is this idea of distinguishing the difference between arcs. So we talked about arc AB earlier. So if I say go ahead and highlight arc AB, it is possible that someone could go from straight A to B, which would make sense because they're pretty close. But there could be someone that says, okay, well, I'm going to go from A and I'm going to go to the left all the way to B, and think, well, technically I've highlighted from A to B. So in order to avoid confusion and making sure we always know which arc we're talking about, because it wouldn't make sense if I'm highlighting one arc and you're highlighting a different arc, we need to distinguish the difference between these. And so the shorter arc, we call the minor arc. And the larger arc, we call the major arc. So major meaning it covers the majority of the circle, and minor, it covers the minority of the circle. So how do I tell the difference in notation, and how can I specify which one I'm talking about? Well, you'll notice the notation for major arc, I've included 3 letters. And so what this does, instead of, if you'll notice the minor arc only has the 2 letters AB, major arc has also the AB, but includes a point in between. So when that tells me, if I say identify the major arc, you're going to tell me, okay, well, that's A, that's going to be large, so it's going to go A to D to B. Right? It specifically gives me directions of the order of letters to go to. So A to B is the minor arc versus A to D to B. Right? If you follow the order of those 3 letters. All right, so we need to know this terminology: major arc, minor arc. And in this case, you should notice together both arcs complete the full circle. So if I add up the measurement of ADB, right, if I actually add up the measurement of ADB, arc ABD, plus the measurement of arc AB, that's going to equal to 360 degrees. It's going to equal a full circle. All right, it's just a little side note of information. All right, so I wanted to front load you with that information. Now kind of back to that first problem. So we talked about having a piece of a tree. How can I figure out the center of the circle? So there's two problems we have here. One of them I've kind of worked out for you, but I'm going to explain it, and then we'll use that same strategy on the second one. How can you locate the center if all you have is 2 chords? All right, so if I'm looking at, so on the left side, I'm going to hide this for a second. All right, so I have circle P. I want to figure out where the center of the circle is. Then we want to do our best to draw a circle that goes, or draw the circle that's being represented. If you have a compass tool to use to help you draw circles, then that'll make it easier for you. If not, if you just approximate it, do the best you can freehand, that's fine. So I have these 2 segments. And I want to figure out where the center of the circle is, meaning that these are chords. So what I do know is that the circle is going to go through somehow it's going to has to go through these points. Obviously that doesn't look like a circle. So that's why I have to figure out where the center is. Is the center going to be here, here? Is it going to be down here? So how do I figure out the center of that circle? All right, well, let me show you what I had before. So if I look at one of these chords and I draw in a diameter or another chord that is perpendicular to that, right? You'll notice this looks kind of like the notes that we had earlier. So if I have two chords that intersect, where one of them is the diameter, right? So that's something we're going to draw in. And I go to the other chord, and I also draw in a diameter, right? It has to be perpendicular. You'll notice, right? These have to be perpendicular. These have to be perpendicular. You'll notice that there's an intersection point here. That is where the center of our circle is. So what I've done is I've kind of just sketched in, done my best to make sure it's a perpendicular. It has to make sure it looks 90 degrees. And I keep drawing it in. Depends on how far you need to draw it. I didn't draw on the whole line, but I probably should have. And then once I have that marked out, and I do the same thing here, I try to create a perpendicular line, and then I notice where they intersect. And that's where I'm going to put this, make the center of my circle. Now, if you're using a compass, you would put the center at that point that we've created, and then while that's there, you would put maybe your pencil, and then you would make a circle that goes around. Right? If you can't, if you don't have a compass or you don't have that tool, then things that you would look at are obviously the center. Make sure you know where your center is. Look at the key points. Look at the key points. And you're probably going to have to do your best to sketch it. Just kind of look at it. Might take you a few. It's okay if it even looks jaggedy. And then you just kind of go around so that it looks like a decent looking circle. It doesn't have to be nice and smooth. You just have to generate a circle that's going to go through these endpoints, and it pretty much looks like it's the same distance to anywhere on the circle. All right, so let's try that with circle Q. So what we just did, this is circle P. We're going to look at circle Q. Where's the center of this circle? All right, well, let's try this. So let's do, let's start with this segment here. So I have this chord. I know this is a chord. And so somehow I know I'm going to have, I need to create a perpendicular line. So perpendicular would be something that looks like this, 90 degrees, but it also has to bisect that line. So it has to be right in the middle. So I have to find the middle of this line. It's pretty close to where that other point is, but I'm not going to, I think I'm going to mark it maybe somewhere around here. And then I'm going to do my best to sketch a line that's perpendicular. So you might, I like to put dots just to make sure. All right. So it's going to look something like this. Right? I just kind of draw it pretty lengthy. And so there is, hopefully it's close enough. This is a 90-degree angle. Should look like a 90-degree angle. All right, now I need to do the same thing with the other chord. I'll use a different color on this one. And I need to find a point right in the middle, somewhere in the middle. Do your best to approximate where the middle might be. And then draw a line that's perpendicular again. Again, I'm going to try to use dotted lines. And then that should be 90 degrees as well. So I'm not going to keep drawing it long because I already see that they've intersected. So now I have this point of intersection that's somewhere right here. So now I have an idea of where the center of my circle is. So you do your best to kind of sketch a circle that's going to go through these points. And see if I could do this. I'm going to approximate it. And so if this is about the right size, that's pretty close. Now I'm doing this on my iPad, so it's I think it would be a little bit more accurate if I was doing it on paper and pencil. And I was using a compass. I don't have a compass, so I'm using the tools of my iPad to create a nice circle, but right now it's really just an approximation. So you could see that this circle's perfect, but I've adjusted it, and you notice it actually goes through these exact points. 1, 2, 3, 4 points. All right, so this is a good indicator of our center is pretty, if it's not accurate, it's pretty close to being accurate. All right, so it'd be confusing if I thought my center was somewhere down here. So, all right, so that's a general idea of how you would find the center of your circle. And really the only way we were able to do this is because we would understand this relationship between a chord and the diameter needing to be perpendicular, which is on the notes earlier. So they're related, even though we're pretty much working backwards to actually create a circle. All right. All right, so that's something you definitely need to know how to do, or at least that relationship between the chords. Now let's look at a couple of problems where we'd actually be doing some calculations to find some missing measurements. So this is more like a question you might see on a test. So we have this circle. We have a circle and a chord given to us. So we have chord WX, highlighted in green. And this is in circle with center Z. So if we have, just like lines or shapes, we have to be able to give them a name. So a circle is given a name based on the center. So if you know the name, the center point, then we call it by that name. And then you'll notice this notation. It actually looks like a circle with a dot inside, which is the center. So it's circle with center Z. Right? So that's how you would read that. If I give you, if I called it circle with center X, then that means the X would be at the center. If it was circle with center A, if this was an A, then I would have an A here at the middle. All right, so circle with center B, or circle with center D, right? So that's how you would write that. So if WX in this picture is equal to 8, having a length of 8 units, and the radius of the circle is equal to 5, how far from the center is the chord? So this might be a little bit tricky. It says how far from the center is the chord? Well, the chord has multiple points, right? It has many points. Now each of them is going to be a different distance from the center. So I really want to see what's the shortest distance from the center to the chord. So if I zoom into this, because I could go from the center to, let's say, here, and that's going to be a different distance from here to here, right? So all these distances, you'll notice it gets further and further. And so I want to know what this measurement is. How far is that? How in the world are we supposed to figure that out, right? So they gave us some measurements. And in this case, they said Wx equals to 8. So that means this whole Wx is equal to 8. That's okay. We're going to work with that. They've also told us our radius is equal to 5. Well, you should notice there's no radius drawn in this diagram. That's okay because you could always add it. So the tricky part here is, where do we want to add it? So we could draw in a radius maybe going straight down and say, oh, that equals to 5. We could draw it going to the left, say, oh, that equals to 5. All right, so we pretty much put it wherever we want. Where could we put it so that it actually helps us in this problem? Well, if we're talking about Wx, we probably want our radius to interact with Wx. So you could, some common thoughts are, well, maybe if I do this, and if I know this is 5, then some common mistake, people say, well, if this is 5, then this is probably 2, and this is probably 3, and then that's it, I'm done. All right, that might be true, but we might need to do some calculations to figure that out for sure. All right, so let's see if there's another place. Well, suggestion I would make is to actually draw in maybe from W to Z, we know has a measurement of 5, right? And so I know this is 5. We also happen to know that if I draw in a point to the other, a line to the other points, let's see, Z to X, that's also 5. All right, well now what we've done is we've created this triangle. So now this means technically we could start using information maybe we know about triangles and how to find distances. But the distance we actually want is the shortest, which is this one. So if I extend that, so the question is, how can I use this information? Well, if we remember, if I have a diameter and it's perpendicular to another chord, then it also bisects that chord, which means these two segments are the same. Well, Wx was equal to 8, which means, let me ask you this, if Wx is equal to 8, what's the distance from W to this intersection point? Right? Well, how long is that? If you said 4, you'd be correct. So this is equal to 4, this is equal to 4. And so I'm looking at this and I'm like, oh, this looks like a right triangle. Why? Because it is. So there's a right angle, and I notice I have 2 of the measurements, and all I have to do is figure out the third one. All right, so what I'm going to do, I'm going to remove this line here because I really don't need that other part of that triangle. I'm only focused on that right triangle. So what we've done is we've turned this circle problem really into a triangle problem. So how are we going to find the missing side of this triangle? So now this has become All right, so there was the radius of 5, and then there was this measurement of 4. So then the question is, what does this measurement equal to? So let's call this, I'll just give it a letter Y, since that letter is not being used. All right, so how do we find, which tool are we going to use to find the missing side of this triangle? I'll give you some options, see if you could think of them. Right triangle tools that we have Pythagorean theorem, we have trig ratios, sine, cosine, tangent. We have special right triangles, 30, 60, 90, 45, 45, 90. Which one do you think we're going to use to solve for the missing side? All right, if you said Pythagorean theorem, then you're correct. All right, so go ahead and solve that. I'll set it up for you, and then I'll let you solve that. So we're going to do y squared plus 4 squared equals to 5 squared. All right, what does y equal to? All right, as we work this out, you'll have y squared plus 16 equals to 25. Y squared equals to 9. 25 minus 16 is 9, which means y equals to the square root of 9, which is 3. All right, so how far from the center is the chord? The center is 3 units from the chord. All right, so as long as we know the measurement of the chord and the radius, we were able to figure out, using Pythagorean theorem, that shortest distance, which was, just for clarification, this is what we're trying to find. All right. Hopefully that makes sense. So if you didn't know Pythagorean theorem, if you don't know how to find for missing sides, this would definitely be challenging for you. And if you didn't understand the relationship between diameter and a chord, then there would be no way you would know that you could actually use right triangle tools to solve this. All right. The next problem I want us to look at is focused not on chord measurements, but on angle measurements. So there's 3 separate questions here. They're not connected. So if you know the answer to one, it's not going to help you on the answer to the other. So these are 3 different questions. Here we have a circle with center B. B is the center of the circle. In this case, AD, segment AD, or chord AD is the diameter. We also have chord AC, and we also have a radius BC. All right, so diameter, radius, and chord. All right, so make sure you know those parts. If measurement of angle A is 35, so angle A in this situation, we're talking about this angle here, 35. I want to know what's the measurement of angle CBD. So CBD. Right, so I want to know this angle. All right, so this is our central angle. I want to know what's the measurement of this central angle if the angle A is 35. Is there any way for us to figure this out? All right, so make sure, hopefully you have this copied down, because I'm going to zoom into this for a second. So 35, I'm going to write on this. So what I know is this is 35. And I also see that I have a triangle here. And something I know about this triangle, it's an isosceles triangle where AB and BC are both a radius, so that means they must be equal to each other, which makes this an isosceles triangle, which then tells me this angle here must also be 35. And using that information, how could we figure out this measurement? So a little bit of trick here I would say is, what if there was no circle? Right? If I take out the circle, this is really not even a circle problem anymore. This is really an angle relationship problem, and I'm asking you, what is the measurement of CBD? So I'm going to see if you could figure this out. I'll give you a couple of clues. You could either use 2 steps, triangle angle sum theorem and supplementary angles, or exterior angle sum theorem. I'll let you decide what's easiest. I'll give you a second to do that and let me know what the measurement is of this angle. All right, so I'm going to put the circle back. Let's see if you got this. I'm a fan of the exterior angle theorem, which says that the two remote angles is the sum of the two remote angles is equal to the exterior, which means this is equal to 70 degrees. All right, let's see if you got that correct. So that means you would have gotten 110 inside and then 70 to complete the 180. All right, so that means I'm going to write this out here. This is measurement of angle CBD is equal to 70 degrees. All right. So let's, I'm going to remove that information. All right. So let's change this problem up. And it says, okay, well, what if CBD is equal to 100? What is the measurement of angle A? All right, so CBD, they've given us different information now. So they've told us this angle here is 100. So now that you get an idea of how these angles are related, what is the measurement of angle A? See if you could answer that one. I'll give you a hint. Right? Think about the relationship between these 3 angles. Right? Ignore the circle if you need to. Work backwards. All right. So what is measurement of angle A? All right. Let's see if you got this correct. So we talked about these 2 angles here. These are isosceles, so these 2 angles have to be equal to each other. What 2 angles, when you add them together, they're going to give you 100. And they have to be equal, right? So if you said 50 and 50, that would be correct. So that must mean angle A is equal to 50. So hopefully you got that correct. So measurement of angle A is equal to 50 degrees. And then, so if I say measurement of angle A is equal to X, so I just call this measurement X here, what is the measurement of angle CBD? What is this exterior angle? How are they related? So your answer is going to be in terms of X. It's not going to be an actual measurement. So if this is, I'll give you a hint. Earlier we said if this was 35, this one was 70. Earlier we said if this is 100, then this must be 50, right? So if A is 50, then the central angle is 100. If A is 35, the central angle was 70. If A is 10, central angle is 20. All right, so if A is X, then what is this CBD equal to? All right, if you said, let's see if we got this correct, measurement of angle CBD is going to be equal to 2x. Right? It's going to be double of the measurement of angle A. All right. If you put 2 times the measurement of angle A, that would have been fine as well. But it should have been in terms of x, so 2x would have made more sense. All right. That's all I have for you on this lesson. The next lesson we'll go into more practice and more information about circles and chords and more relationships and angle relationships as well. All right, let me know if you have any questions and we'll see you next time.